everyone. This is Diane Fodell. Thank you for joining our Cognitive Systems Institute speaker series this morning. I'm happy to introduce Hironobu Takagi, who is a senior technical staff member and technical leader for cognitive computing research at IBM Research in Tokyo. He's the originator of the Accessibility Tools Framework, a designer, which is an Eclipse-rich client platform application that enables application developers to ensure that content, applications, and web pages are accessible and usable by the visually impaired. He's an editorial board member of ACM Transactions on Accessible Computing, and he's the recipient of numerous awards and author or co-author of several books. I met Hiro this January at the Hicks Conference in Hawaii, where he presented his great work as part of the cognitive tutorial at the conference, and I asked him to join us today to present to this audience. Please help me welcome Hiro, who will present Cognitive Assistance for the Aging. I'll turn it over to you, Hiro.
Thank you very much, Diane. Hi, everybody. I'm Hiro Takagi. I'm calling in from Tokyo, and I'm a researcher at IBM Research Tokyo and working for Aging Strategic Initiative in IBM Research Global. So today, I'd like to introduce some activities around elder care. So we have global team, and I will pick a few topics from the global activities. Okay, so the second page. So the world is aging. I believe everybody in this call is already aware of this fact. This chart shows the percentage of population of people over the age of 65 in each country. And you can see the trend. Every country goes up. And Japan has been leading ever since 2004. And that is why we should be the role model for other countries. So what is happening in Japan and what you can expect? So the life expectancy increased from 62 years in 1950 to 87 years in 2014 for women in Japan. Amazingly, it extended 25 years. We call this life expectancy revolution. And it's of course, it's good actually. And we have 25 more years. The question is, what should we do in this extended 25 years? So what do you want to do if you have 25 more years? So that is a fundamental question. So actually, this is a societal challenge we have. How can we make this extra time meaningful and improve quality of life of people? So here we have one good news. 70% of people want to work over the age of 70 or forever. They want to be active members of our society. It's really good news. But here is bad news. 28% of people over the age of 65 are at the risk of dementia. 15% of people already have dementia, and 30% of people are one step before dementia. So, and the cost is skyrocketing. The dementia care costs $145 billion, or 3% of the GDP for Japan. It's huge, and we cannot stand without changing this trend. So that is a big challenge. So now we need a new model for active lifelong society. No retirement work style or home care technologies, and economical model for elder care. We need to change almost everything in our society. So IBM Research has been working for many years to contribute to such societal transformation. We started from information accessibility for the elderly and expanded the activities toward social computing technologies to connect the elderly to family members, caregivers, and community members. Let me start from this topic. And actually, we worked with universities by getting support from Japanese government and experimented latest collaboration technologies like video telephony and telepresence technologies. And based on the experiments, results from these experiments, and we started this pilot with Japan Post. Japan Post is a postal company, but they have a large human resource across Japan. And so societal isolation is one of the most serious problems, and many elderly people live alone remote areas far away from their children who live in urban areas. So the younger generation always worry about their parents, but it is not so easy to give up their jobs to go back to their home countries. That is why we created a set of apps to connect elderly people, caregivers, and children. So you can see the screen of the app. So that the app provides a set of services such as healthcare check, medication reminders, video telephony, online shopping, and photo sharing. The top right image shows a scene. A Japan Post officer visits a house and provides information on how to operate the app. So this kind of support is critically important for novice elderly people. And when a user responds not feeling good to the health check, the information is automatically sent to their children and shared with caregivers. And they can call her via video telephony. Right bottom is a scene from a video. So, and in order to enable such pilot services, we developed three apps for elderly users, for younger generation, and for caregivers. The app for elderly user was designed to be accessible even for novice users. And we defined the design guideline based on our expertise, and also we provided courses by postal office workers. And so actually this model was recently applied in Italy through collaboration with Italian Post. The model is the same. They have huge human resource and they can utilize their staff to change the model for caregiving. So now we have a new business model here, but here is a big challenge. The psychological barrier of novice elderly users to start using mobile devices. And you can easily imagine that it's not so easy to overcome such barriers. So here is a hint. we integrated a small voice input feature in the pilot app. And we observed some of the elderly users input diary to the system every day. And we found speech is much more natural to them, and also using new technologies is fun for them as well. So, and it's a good experience for us. And we came up with the idea of conversational elder care systems. So this led to us the next topic, intelligent assist. So this chart shows our approach. We call it conversation as sensors. So Watson in the middle talk to the user every day about the usual topics like weather, events, meals, and daily activities. The key point here is an analysis engine. We developed an engine to analyze life patterns, cognitive issues, feelings, interests, and other insights about elderly users, and then send alert and reports to support workers and family members. So let me show you a demonstration video.
Hello さん、こんにちは。Hello さん、こんにちは。Hello さん、こんにちは。
こんにちは。
ご機嫌いかがですか？
はい、元気だよ。
それはいいですね。今朝のお薬はもうお飲みになりましたか？
うん、飲んだ。
それはいいですね。もしお困りのことがあれば、お医者さんに相談なさってくださいね。ところで、昨日はどこかへ出かけましたか？それともお家の中にいましたか？
昨日はうちの中にいた。
そうですか。昨日はお家の中にいらっしゃったのですか。それでは、昨日の晩ご飯は何を召し上がりましたか？よろしければ献立を教えてください。
カレーライス。
もう少し聞かせてください。日記に植木のことを書かれていましたが、植木関連のお仕事に興味がありますか？
少し興味ある。
今月は松の緑摘みがありますよ。後で詳細をお送りいたしますね。最後に iPad でお困りのことはありませんか？
家族にテレビ電話をかけたいんだけど。
家族の顔写真を選んでテレビ電話で話すボタンをタッチしてください。他に何かお困りのことはありませんか？
今は特にない。
Okay, this is the end of the demo. So the conversation is natural, and also we designed and we carefully designed the conversation, and each questionnaire has a specific intent. And for example, what did you have last night is usual conversation, but the intent is this is one of the dementia risk assessment questionnaire. So and we can assess, we can accumulate the assessment, small assessment results by using this questionnaire. And did you go out today is activity checking, is a very important information for assessment, various types of assessment. And also we can integrate recommendation. So you mentioned about gardening in diary. Are you interested in community gardening? So this is, this is intended, so this is targeting to activate the activity of the elderly user. And also the more business side questionnaire. Which city do you want to travel? This is a kind of marketing. This will be a marketing questionnaire for travel agencies. So the shop you mentioned last week is now on sale. Can be a promotion. And so we can integrate various types of scenarios and business needs in this simple user interface. So we believe that is the power of conversational elder care approach. And not only textual analysis, we can integrate other analysis technologies like voice sound analysis. So this is an example of such approaches. And so we integrated the voice emotion recognition technology from Yorktown Research Lab. So by using this technology, we can classify each voice sound to negative voice to positive voice. So, and by using this technology, not only textual information like I'm fine, just the users say I'm fine, but we can assess it's really fine or not so fine. So, and we can apply multiple dimensions to the analysis. So, and then we prototyped this dashboard. So this dashboard is an integration of various types of analysis results. And for example, and condition is based on the questionnaire. Emotion is from voice sound analysis. And personality analysis is based on all the speeches from the user, and also we are using the Watson Personality Insights as the analysis engine. And the visualization on the left side shows the daily diversity of daily activities, and also we can visualize diversity of foods as eating habits. And also we have results from dementia-related questionnaire, dementia assessment questionnaires, and other informations. So we can analyze various dimensions, and we can integrate those results into this dashboard to share with family members and also caregivers. Okay. Okay. So the final topic is brain. So in order to study the mechanism of Alzheimer, we also work for the computational neuroscience. because the root cause of the challenge of the aging society is brain. So that is why this brain science side activity is critically important for our future. Ah, sorry. Yes, and the societal. This chart shows the societal impact of dementia, and Alzheimer is sixth leading cause of death, and only one disease we don't have any method to cure. But we have intervention methods if people are in not in dementia, in MCI status. MCI is just one step before dementia. But the challenge here is screening. Only 50 to 95% people with dementia never had screening. So this is a big challenge for early detection. So that is why we explored new method for early screening. And actually, the gate is very informative in this area. So when the brain slows down, his gait also slows down. So that is why gait performance can be an earlier indicator for dementia compared with a sensible cognitive decline. On the right side chart shows the such possibility of early indicator. Okay. So, if we can analyze gait features like gait speed, variability, and step frequency, stride time variability, and these kinds of features from the everyday gait behavior, and we have possibility to early detect, fall risks and cognitive decline or more diseases. So now that's why now we are trying to develop new technologies to analyze the gait motions. So let me show you our demo. So based on the abstract Kinect data, we applied anatomical data, robotics technologies, and also optimization technique to estimate the bone, joint, and muscle motions. So you can see the visualization. So in this visualization, red muscles are activated and blue muscles are not. So you can see the details of the gait features by using this. So, and we hope to expand this technique to be utilized in various locations. Home environment is one possibility, and elder care home facility is another possibility. And the final topic is brain simulation. And so and we created a brain model. It's a virtual brain model based on MRI data from the Alzheimer gene carrier and non-carriers, and and we compared the bio features from these two models by using virtual stimulus, and we found the biological differences between two brains, especially for information propagation. And this is an early result from this simulation, but we hope these results will be the basis for the future treatment for the Alzheimer. Okay, this is the final slide. So today I focused on 3 topics: social, intelligent assist, and brain science. And also other global teams are working for other technologies. For example, an Austin team is working for technology to analyze IoT sensors in homes. And also we have robotics team. They are working for the elder care robot beyond the conversational interface. So the challenge is big, and more technologies are needed. And we hope to work with our partners to change this aging world to be more active and healthy by these technologies. Thank you very much.
Thank you, Hiro. That was great. And we have just a couple minutes for questions. So audience, please press *1 to unmute your line and ask questions.
Hi, this is Sue Feldman. We actually put together a custom version of what you're doing for our own aging parents. It was tremendously successful, and it makes me wonder if you have considered using some of the technology that was developed by IBM, I think Israel, on network analysis and recommendations for connection, because one of the things we found with our aging parents was that they were eager for not only continuing to groom their own network, but to reach out to others who might have similar interests. It's a touchy kind of thing. You can't, just recommend anybody. But what I saw several years ago at IBM was very encouraging in this regard, and community development could be an interesting thing. Thank you.
Hiro, could you move your connecting and thinking of your interaction to a more educational one for the person who's using it? In other words, this would be studying not only the things you've done, but how they learn, and then helping them to move forward in areas they want to learn new things, and build a new community of interest, or study a particular new topic, or listen to new kinds of music, or whatever, so that their interest would be continuously built, not just as a tool, but as a helper and as a beginning of a coach.
Thank you very much for the question. So the first question, yes, and we are actively exchanging information with global research labs. So Haifa and Zurich, Ireland, and Austin, New York. So we have a global team. So yes, and we will try to collaborate with the technology from global teams, and we will seek the possibility for such opportunity. And as for the education part, and actually, we worked with some an aging community for remote education technologies as a part of social computing experiments, and it worked pretty good. And one expert community provided some lectures to some remote community, and it worked well, and yes, and such educational or skill improvement, continuous or forever. I mean, continuous skill improvement among elderly is critically important, I believe. Yes, I totally agree. So, and we hope to work in the area, with some partners in the near future. Thank you very much.
Thank you for the questions. Thank you, Hiro, for staying up so late in Japan to present to us. Audience, thanks for your participation. We'll continue the conversation with Hiro on our LinkedIn discussion group. And thanks for attending. We will see you next week. Thanks again, Hiro. Great presentation. Great work.
Thank you very much. Thank you very much, everybody.